Hi guys, I'm Raphael and I'm here to teach you how to solve optimization problem. Oh, not really me but my friend Jona. So, let me call her.
Hello?
Hello Jona, can you teach me how to solve optimization problem?
Of course, no problem.
Oh, okay.
What are optimization problem? In calculus often involve the determination of the optimal value of a quantity. For instance, we might want to know the biggest area that a piece of rope could be tied around. Very often, the optimization must be done with certain constraints. In the case of the rope, we're limited by its length. These constraints are usually very helpful to solve optimization problems. Optimal values are often either the maximum or the minimum values of a certain function. Examples. We need to enclose a field with a rectangular fence. We have 500 feet of fencing material and the building is on one side of the field and so won't need any fencing. The first solution is to illustrate the picture. The next step is to create a corresponding mathematical model, which is A equals xy, and our constraint is x plus 2y equals 500. We now solve the second equation for x and substitute the result into the first equation to express a as a function of one variable. X plus 2y equals 500. X will be 500 minus 2y. Substitute that equation to a equals xy. It'll be a equals 500y minus 2y squared. Then, x will be greater than or equal to 0. Substitute the value of x, which is 500 minus 2y. Then it will be 500 minus 2y is greater than or equal to 0. 500 is greater than or equal to 2y. Then you will get 250 is greater than or equal to y. This will be your basis to prove that the values are right. Next is to find the y value. A prime of y will be equal to 500y minus 2y squared. Simplify until you get 500 equals 4y. Y will be 125. After getting the y value, which is 125, substitute it to the equation x plus 2y equals 500. And you will get 250 as your x, and y will be 125. Thus, making the proving that x is greater than or equal to 0 true with 250 is greater than or equal to 125. X is 250 feet and your y will be 125 feet. Example 2. We want to construct a box with a square base and we only have 10 square meters of material to use in construction of the box. Assuming that all the material is used in the construction process, determine the maximum value that the box can have. First, draw a picture. Next step is to create a corresponding mathematical model. We now solve the second equation for h and substitute the result into the first equation to express v as a function of one variable. Since w is greater than 0, we can use only the first derivative test for absolute extreme values. The derivative of v as a function of w is. Therefore, the maximum value of the volume must occur at w equals R53. Finally, the dimensions of the box are. That's it!
Okay, Jona, thank you. I learned a lot from you. Bye! And that's all. I hope you learned a lot from our video. Thank you.